Hi everyone. In today's video, I'll be talking about a way to find the solution for problems using prime factorization. So consider this problem. Find positive integer values for a, b, and c that satisfy the given equations 1 and 2. So in equation 1, as you can see, 10a is equal to 3b squared, and in the second equation, 6a is equal to c squared. So we need positive integer values for a, b, and c. So step one here would be to analyze the problem. So when we look at equation number one, 10a is equal to b squared. From this equation, we can also get b is equal to root of 10a, which is also equal to root of 2 times 5 times a. Since b is a positive integer, a must have prime factors of 2 and 5. Because the root of a square can only be a prime integer, so this has to be a square. And for this to be a square, we need a to have prime factors of 2 and 5. Assume a is 2 to the power of x times 5 to the power of y times n to the power of n, where x is an odd number, y is an odd number, and n is an even number. Now b is equal to 2 times a root of 2 times 5 times a, which is also equal to, when we look at this times this, we get 2 to the power of x plus 1 times 5 to the power of y plus 1, and then we keep the n to the power of n, so times n to the power of n. And I'll note here that x plus 1 is and y plus 1 are even numbers, and n has to be an even number, which also means x and y are odd numbers, and n is still an even number. So now we can analyze the second equation, 6a is equal to c cubed. So from this equation, we can get c is equal to the cubic root of 6a, which is also equal to the cubic root of 2 times 3 times a. Since c is a positive integer, a must have prime factors of 2 and 3. Because naturally, if we're making a cubic root of something and it equals a positive integer, this has to be something to the power of 3. Now, assume a is equal to 2 to the power of x times 5 to the power of y times m to the power of n, and now times 3 to the power of z, because we need a prime factor of 3. We can replace it in the previous equation. C is equal to the cubic root of 2 times 3 times a, which is also equal to the cubic root of 2 times 2 to the power of x plus 1 times, we keep the 5 to the power of y, times 3 to the power of z plus 1, and times n to the power of n. Now here, x plus 1, y, and z plus 1, and n are all multiples of 3, because we're making a cubic root and it has to be a positive integer. So step 2 here would be solving for a. So a summary of the above analysis, we got a has prime factors of 2, 5, and 3. Assume a is equal to 2 to the power of x times 5 to the power of y times 3 to the power of z times n to the power of n. We also have x and y are odd numbers, n is an even number, x plus 1, y, z plus 1, and n are multiples of 3. So the minimum values for x, y, z, n are 5, 3, 2, and 6. So x has to be an odd number, and x plus 1 has to be a multiple of 3. The smallest we have is 5, and 5 plus 1 is 6, which is a multiple of 3. Y is an odd number and multiple of 3, which only leaves us with 3 for the minimum value. So z plus 1 is a multiple of 3, so z for the smallest value would be 2. And n is an even number and a multiple of 3, so the smallest value we have is 6. So now a is equal to 2 to the power of 5 times 5 to the power of 3 times 3 to the power of 2 times m to the power of n, which n is 6, so n to the power of 6, which is also equal to 36,000 m to the power of 6. Now the smallest a we have is 36,000 when m is equal to 1. So now that we found A, what's left is to find B and C. B is equal to root of 10A, which is equal to root of 10 times 36,000 m to the power of 6, which is 600 m to the power of 3. And the minimum for B would be 600 when m is equal to 1. So C is also the cubic root of 6A, which at the end gives us 60m squared. And the minimum for C would be 60 when m is equal to 1. So now we found A, B, and C, which their minimum values are 36,660 respectively. Thank you very much for watching and see you next time.